Have you ever tried to race with light? It's a funny thing to imagine, isn't it? Bare feet on a dew-covered hill, sunrise just peeking over the edge of the earth, and you, heart thumping, arms swinging, sprinting to keep up with something that has already touched the mountaintop before you even felt the wind stir. Light is fast. Not just fast, unbelievably, profoundly, impossibly fast. But why? Why does light have a speed limit, and why is that limit so strangely specific? Welcome to this cozy corner of curiosity. I'm so glad you're here. Whether you're settling in for sleep, resting your eyes after a long day, or just floating gently through your evening, I invite you to relax, breathe, and journey with me through the gentle mysteries of the universe. If you enjoy this calming dive into wonder, I'd love for you to like and subscribe. It helps this quiet little channel find its way into more hearts, just like yours. Now, shall we begin? Let me tell you a story. Not a story about kings or dragons, but one about something just as wondrous, how we humans, curious creatures that we are, came to discover that light doesn't run wild and free through the cosmos, but rather, it tiptoes along at exactly 299,792 kilometers per second. Not a step more. Not a step less. But we didn't always know this. No, once upon a time, people thought light traveled instantly. Blink and it's there instantly. If you lit a lantern at night, it flooded the room without delay. The moonlight reached us with silent grace. So how could it not be infinite? Let's drift back, just a little, to a time when Galileo, the starry-eyed dreamer of Pisa, climbed a hill with a friend and 2 lanterns. Imagine it now. The sky is deep and dark. Crickets hum their lullabies. Galileo stands on one hill. His assistant stands on another. Both hold shuttered lanterns, their breath fogging in the evening air. Galileo opens his lantern, and as soon as his assistant sees the light, he opens his in return. Galileo watches. Times it. Wonders. Did the delay he noticed come from the assistant's reaction time, or from the light itself taking a moment to travel? It's hard to say. And as you can guess, the difference was far too small to measure with their tools, their eyes, their human clocks. Still, the question had been planted. Light, perhaps, was not infinite after all. Centuries passed. The world changed. Empires rose and fell. But light kept dancing across the universe, unnoticed, unmeasured. Until, one day, a curious Danish astronomer named Ole Romer watched the moons of Jupiter. Now, that may seem like a strange place to find an answer. But science often hides in the strangest pockets of the sky. Romer had been studying Io, one of Jupiter's moons, watching it orbit again and again. But sometimes, Io seemed late. Not by much. Just a few minutes. Like a guest you know is reliable, but who shows up slightly off schedule when the weather's bad. At first, he thought maybe his math was wrong. Maybe Io was being a bit unpredictable. But then it clicked. As Earth moved away from Jupiter in its own orbit, the light from Io had to travel just a little bit farther. And as Earth moved closer again, the light had a shorter distance to go. It wasn't Io that was late, it was light that was taking its sweet time. Romer calculated it. He measured it. And just like that, he became the first person to put a number to light's speed. Not the exact number we use today, but close enough to realize, light doesn't cheat. It has a speed. A very fast, very real speed. Now, let's pause for a moment. What's the time in your corner of the world? Are you tucked in, blanket pulled up to your chin, phone screen dimmed, listening in the soft hush of night? Or maybe you're drifting in a train seat, watching lights flicker past the window, wondering if those glimmers understand how fast they're really going. Let's float gently back to our story. You see, once scientists knew light had a speed, they began to wonder why. And that question led them somewhere unexpected. To clocks. And time. And the fabric of space itself. Because, as it turns out, light's speed isn't just fast. It's the fastest. The cosmic speed limit. No information, no object, no anything can go faster. But why? Imagine the universe as a vast stage made of woven threads. Some of these threads are space, length, width, height. Others are time, tick, tock, tick. And light is the needle that threads them together. Einstein, that wild-haired thinker with eyes full of dreams, peered into this woven fabric and whispered, "Time and space are not separate. They are one." And light is their constant companion. He called this idea relativity. A beautiful word, isn't it? It sounds like family. Like connection. Einstein showed us that the speed of light isn't just fast, it's fundamental. Unchanging. Even when you're moving, even when you're flying, even when you're drifting in the vacuum between stars, light moves past you at the same speed. Always. It's as if the universe bows to light, letting it glide through space-time as the one true constant. But here's the funny thing. To make light's speed constant, the universe has to bend. If you move faster, time slows down for you. If you move faster, lengths shrink. The very rhythm of the cosmos warps so that light's speed stays steady. It's like the universe is a grand conductor, keeping all instruments in tune just so light can keep its beat. Now, you might be wondering, if nothing can go faster than light, does that mean we're trapped? Stuck forever within its slow, steady wake? Well, not quite. Because light's limit gives us something too. It gives us causality. That's a big word. But it simply means that things happen in order. That actions lead to results. That your yawn leads to your stretch, and your stretch leads to that warm feeling of sinking deeper into the mattress. If light could go faster, if information could leap ahead, then effect might arrive before cause. The cup would shatter before it fell. The door would creak before the wind blew. The universe would become a surreal painting, full of backwards brushstrokes and upside-down time. So light's limit, in a way, keeps the story of the universe readable. You know that feeling, when you're deeply absorbed in a novel, and the plot flows just right, each sentence following the last with quiet purpose? Light does that for reality. It's the spine of the book. And so, next time you flip a light switch and the room flickers bright, or you watch the sunset stretch in amber ribbons across the sky, think of this. You're not just seeing photons. You're witnessing the rhythm of the cosmos. Now, before we let this chapter close, may I ask, where are you listening from tonight? Are you near the sea, with the gentle hush of waves in the distance? Or high in the mountains, where starlight feels just a little closer? Wherever you are, know this, the light that touches you traveled far, but always within the rules. Always within that curious limit. A limit that binds the universe together. A limit that whispers, even in a place as vast as this, there are rules, and rhythms, and reasons. And in those reasons, we find wonder. If you enjoyed this quiet journey into the speed of light, I'd be honored if you left a soft thumb of approval, or shared this story with someone else drifting through the cosmos tonight. Let's build a little constellation of curious hearts, together. Now rest easy, dream softly, and know that even light, as fast as it is, still moves slow enough for us to follow. Have you ever tried to catch a shadow? They're slippery little things, always just out of reach, darting behind walls and under chairs, stretching across grass in the afternoon sun. But they're not really running, are they? They're only following light. Wherever light goes, a shadow is sure to trail behind. Tonight, let's follow the light once more. Not in a chase, but in a soft stroll through the history of how we tried to measure it. And maybe, along the way, we'll discover why it matters that we even tried. Hello again, dear listener. I'm so glad you've returned to this quiet corner of curiosity. Whether you're curled up in bed with the moonlight slipping through your window or nestled into a cozy nook with soft rain drumming against the glass, this time is yours. Let the world outside grow distant. Let your thoughts slow. And if this little story brings you peace or sleep or a smile, I'd be honored if you tapped like or shared it with someone who might need a moment of calm, too. Now come, let us return to the mystery of light. Last time, we met Galileo and Romer, peering into the dark with lanterns and Jupiter's moons, trying to understand if light had a speed. And we learned that yes, it does. A speed, precise and unchanging. but we still didn't know exactly what that speed was. Not yet. Let's float forward to the 19th century, where two French physicists, Hippolyte Fizeau and Léon Foucault, would bring light down to Earth and make it dance through gears and mirrors. Imagine it with me, will you? A long hallway. At one end, a bright, focused beam of light. At the other, a rotating toothed wheel, spinning with careful rhythm. Fizeau shines the beam through the gaps in the wheel, across a great distance, to a mirror, and back again. But if the wheel spins just fast enough, the returning light is blocked by the next tooth. It's a bit like trying to thread a needle while riding a carousel. By adjusting the spin, by measuring the distances, Fizeau could estimate how long it took the light to make the journey out and back. And from that tiny time, he calculated something huge, the speed of light. A real number. Around 313,000 kilometers per second. It wasn't perfect, but it was close. Then came Foucault, with his elegant mirrors, twisting gently like ballerinas. His apparatus sent beams dancing across spinning reflections, shifting ever so slightly with time. It was a more precise method, and it refined the number further. Can you imagine the thrill of it? To pluck something as intangible as light from the sky and tame it into numbers. To see the invisible and make it known. And here's a curious thing, the more precise our measurements became, the more we realized something extraordinary. The speed of light wasn't just a property of light. It was a property of everything. But before we explore that mystery, let's pause. Where are you listening from tonight? Are you walking softly beneath streetlights, the glow puddling at your feet? Or maybe you're drifting on a couch, the soft hum of a ceiling fan above you, the world gently muffled like cotton. Wherever you are, this story is for you. Let's return now to a Scottish physicist named James Clerk Maxwell, who didn't chase light with gears or mirrors, but with equations. Maxwell lived in a world where scientists believed electricity and magnetism were separate things. Sparks and compasses, currents and fields. But he saw a connection. A unity. Something deeper, humming beneath the surface. And when he described that connection with mathematics, something miraculous appeared. An equation. Or rather, a set of them. Maxwell's equations. You don't need to know what they look like. Just know that they are like poetry written in the language of the universe. Elegant, symmetrical, and strange. And hidden inside them, like a secret folded in a letter, was a speed. A constant. A number. When Maxwell calculated it, he was astonished. It matched the speed of light. From that moment on, scientists understood, light was not just a beam or a particle or a wave. It was an electromagnetic ripple, a dance between electric fields and magnetic ones, twirling together through space. And the speed at which those ripples traveled? It wasn't chosen by light. It was woven into the very fabric of the vacuum. Into space itself. That number, 299,792 kilometers per second, isn't light's choice. It's nature's. The way a guitar string has a natural note, space has a natural speed. The speed at which electromagnetic waves move. And light, well, light is just one of those waves. Now, that's an astonishing idea, isn't it? It means that even if no stars shone, even if no lanterns flickered, even if no shadows danced, space itself would still carry the blueprint for light's speed, humming quietly beneath the surface of existence. A constant. A law. A promise. Let's linger here for a moment. Breathe in. Let it out. Let your shoulders soften. Let your brow unfurrow. The speed of light is not fast because light wants to be fast. It is fast because nature itself insists on it. And yet, light is not the only thing affected. Maxwell's revelation sparked another. If light's speed is built into the universe, then the idea of something being still or moving might be more complicated than we thought. For a while, scientists believed there must be something, some invisible substance filling all of space, that light traveled through. Like air for sound. Like water for waves. They called it luminiferous ether. It was a beautiful idea. poetic, even. But every time they tried to measure the Earth's motion through this invisible ocean, they found nothing. No ripple. No shift. No wind of ether brushing past. It was as though the ether didn't exist at all. This led to one of the most famous experiments in all of physics, the Michelson-Morley experiment. Two scientists, standing patiently beside their mirrored contraptions, tried to detect the subtle difference in light's speed depending on the Earth's motion. But the result? A great cosmic shrug. Light's speed was always the same. Always. No matter where. No matter how fast the Earth moved. It was the mystery that puzzled the greatest minds of the time. Until a quiet, curious man named Albert Einstein decided to believe it. Instead of trying to explain the constancy of light's speed, he asked, what if it's simply true? What if light's speed is constant, not just in appearance, but in reality? And what if the rest of the universe bends around that truth? It was a bold idea. But it worked. Beautifully. It changed everything. We'll explore that deeper in the next chapter, but for now, let's just sit with this moment. The idea that light's speed is not a trait, it is a truth. And the truth is not negotiable. Not by distance. Not by motion. Not by wish. It just is. And isn't there something comforting about that? In a world where so much feels uncertain, where time slips through our fingers like water and news travels faster than sleep, there is still one thing, one quiet, glowing thing, that always keeps its pace. Light. So the next time you strike a match in the dark, or watch a sunrise unfold over the hills, or glimpse the pale glow of the moon rising slow and sure, remember, you're witnessing a constant. A promise. A speed older than stars. And as you drift tonight, if your thoughts begin to wander, let them follow light, not in a race, but in a reverie. Let your mind float gently across the waves of Maxwell's equations, through Fizeau's gears, and into the mirrored halls where beams bounce like ballerinas. And when your eyes grow heavy, know that even in your dreams, light travels on. Soft. Steady. Certain. Thank you for joining me again on this journey through wonder. If this story kept you company, I'd be grateful if you tapped the like button or shared it with someone who might also need a little calm. There's room in this constellation for everyone. And when you're ready, I hope you'll return for Chapter 3, where we step gently into the heart of Einstein's dream, and learn how light's speed shapes time itself. Have you ever noticed how time feels different when you're waiting? A minute waiting for tea to steep stretches long and lazy, like a cat in the sun. But 10 minutes lost in your favorite story vanish without a whisper. Time, it seems, is a slippery creature. Sometimes fast, sometimes slow. And yet, we all pretend it ticks the same for everyone. But what if I told you, it doesn't? What if I whispered, softly, that time is not fixed? That it flows, bends, and warps depending on how fast you move, just to keep the speed of light the same? Welcome back, friend. I'm glad you've returned to this slow, starlit path through science and story. Whether you're lying down under a soft blanket or listening from a quiet corner of the world with your thoughts like drifting clouds, I invite you to breathe deeply, settle in, and simply listen. If this tale brings you peace, I'd love if you gently tap the like button, or maybe even subscribed. Every little gesture helps this sleepy corner find others like you, curious, cozy, and wide-eyed, even in the quiet of night. Now, let's step gently into the dream of Albert Einstein. Picture a young man in a postal office in Bern, Switzerland. The year is 1905. Outside, horses clop gently over cobblestones. Inside, a quiet clerk reviews patent drawings for machines that hum and clatter. But in his mind, something else is turning. A thought. A question. What if I were riding a beam of light? Not chasing it. Not watching it. But riding it. Sitting atop it like a surfer riding a cosmic wave. It's a beautiful image, isn't it? Einstein wondered, if I moved with light, would it stop moving? Would I see it frozen beside me, a wave of brightness still as glass? And the more he thought, the stranger things became. Because Maxwell's equations, those silent symphonies of electromagnetism, didn't allow for frozen light. They said light always moves. Always. At the same speed. No matter what. And so, Einstein did something quietly radical. He decided to believe them. He imagined a world where light's speed never changed, no matter how fast you were going. And to make that work, he let go of the idea that time and space were absolute. He let them bend. Let's walk through this gently, like tiptoeing through a dream. Imagine two twins. Identical in every way. You are one of them. The other climbs into a spaceship, sleek and silver, and flies away at near the speed of light. Time passes. For you, here on Earth, the days feel normal. The sun rises, then sets. The moon waxes and wanes. Maybe you grow a garden. Maybe you learn to knit. Maybe you just wait. And then, the ship returns. You run to greet your twin, expecting to see your own reflection in the same familiar form. But they are younger. Not just a little. Perhaps by years. While you grew older, they moved fast, and their time, their ticking seconds, flowed slower. This is not a fairy tale. It is special relativity. Einstein's soft revolution. Time, he said, is not the same for everyone. It stretches. Slows. Yields. Not because the universe is broken, but because it is beautifully, fundamentally built that way. To keep light's speed constant, the universe lets time bend. Let that thought settle in your mind like a feather on still air. The faster you move, the slower time flows. That's why astronauts on the International Space Station age just a tiny bit less than those of us on Earth. Not enough to notice, but measurable. Real. Proven again and again. And it goes further. Not just time, but space itself bends, too. If you move quickly, distances shrink. Length contracts. It's as though the universe is a great, stretchable blanket, and light is the one thread it refuses to unravel. Let's pause for a moment. Are you listening near water? Maybe a gentle stream, or the hush of waves just out of reach. Or perhaps the only current near you is the quiet, steady hum of electricity behind your walls, your own kind of river. Wherever you are, let your breath flow with the current. Let your thoughts wander freely, and then return to this calm little story. Let's talk for a moment about time dilation. It sounds complex, but really, it's simple. If you go fast enough, time stretches. If you could somehow travel at the speed of light, which you can't, but we'll dream for now, then time for you would stop altogether. For you, a journey across galaxies would be instant. But for everyone else, millennia would pass. That's why, in many science fiction stories, astronauts return home to find a world that has moved on. Generations grown. Cities changed. Languages evolved. It's not fantasy. It's physics. Light's speed limit isn't just a number. It's a sculptor, shaping time and space into strange, beautiful curves. And what's even more remarkable, this isn't just theory. It's tested. Measured. Proved. In 1971, scientists flew atomic clocks on airplanes, then compared them to identical clocks left on the ground. The ones in motion ticked slightly slower. Time had shifted. Just as Einstein predicted. It was like catching a shadow and discovering it at depth. And all of it, is because of one truth: light moves at the same speed for everyone. Everything else, time, distance, mass, adjusts to protect that truth. Now, that might sound unsettling. A world where time bends, where clocks don't agree, where space itself changes depending on how fast you move. But in another way, isn't it comforting? The idea that the universe isn't rigid, but flexible. Responsive. Willing to yield. Like a quiet friend who always makes room for you on the couch, even when you arrive late. Let's return once more to our twin. You, older now. Them, return from the stars. You sit together under the same sky, sharing stories. Laughing. Wondering. And though your timelines no longer match perfectly, your bond remains strong, unchanged. Because while time may stretch and bend, love does not. Memory does not. Connection does not. Einstein taught us that the universe is more fluid than we ever imagined. But he also reminded us that understanding it brings us closer to truth. Closer to wonder. Closer to each other. So next time you look at a clock and feel like it's dragging its feet, or racing ahead, remember that time is not a single river. It is a sea of tides, moving differently for each of us, all to protect that bright, constant thread of light. And you, dear listener, are part of that dance. You are stitched into the same fabric. You, too, are riding the curve of time. If this journey helped you float a little lighter, or if you found something in it that made you smile softly in the dark, I'd be grateful if you left a quiet like or passed it along to someone else. This little lantern of science and story grows brighter with every heart it touches. And when you're ready, I'd love to have you back for Chapter 4, where we wander into gravity's gentle grasp, and learn how even the curve of the Earth and the stretch of the stars bow to the speed of light. But only if your eyes are still open, and your mind still curious. And if not, then sleep well, traveler. Light will be here when you wake. Have you ever dropped something and wondered where it goes when it falls? Not just down, of course. That's the simple answer. But deeper than that, what does it mean to fall? Does the apple plummet through space like a stone through water? Or is space itself, curved, like a giant hammock, gently guiding the apple along its invisible slope? And what if I told you that gravity isn't really a force at all? Not in the way we once thought. Not a hand that pulls, but a path that curves. And light, brave, constant, ever-speeding light, must follow that curve too. Welcome back, kind listener. Wherever you're resting, be it beneath stars, or in the soft dim glow of a bedside lamp, I'm glad you've returned to this journey through sleepy wonder. We're following light, gently and slowly, into the deeper folds of the cosmos. If this story makes you feel a little more at peace, a little more connected to something quietly grand, I'd be so grateful if you liked or shared it. Every little gesture helps this gentle corner reach another dreamer like you. Now close your eyes, if you'd like. Let your breath flow easy. And let us return to a question: what is gravity, really? For centuries, we thought we knew. Newton told us that gravity was a force, one object pulling on another across space. The Earth pulls on the apple. The moon pulls on the tides. The sun pulls on the planets. Simple. Neat. Beautiful. But something didn't quite fit. Because if gravity were just a pulling force, how did it move? How did the sun's gravity reach the Earth instantly, even across that great emptiness? Shouldn't it take time? Einstein, curious and gentle, had the same thought. And he gave us something even more elegant than Newton's apple tree. He told us, gravity is not a force at all. It's geometry. Imagine, if you will, a great rubber sheet stretched out in the dark. Now place a marble on it, a tiny one. The sheet barely dents. But place something heavier, a bowling ball, perhaps, and the sheet curves, slopes, dips around it. Now roll the marble near the bowling ball, and what happens? It doesn't fall. It follows the curve. That, Einstein said, is what gravity really is. The bowling ball is a star. Or a planet. Or a galaxy. The sheet is space-time itself. And the marble? That's you. That's me. That's light. We are not pulled. We are simply following the curve of the world around us. This idea, general relativity, revolutionized how we see the cosmos. It told us that massive objects bend space and time. That time ticks slower near something heavy. That even light, our fastest traveler, our constant companion, can be caught in the bend. Yes, even light must obey gravity. Let's drift gently into that thought. If you shine a beam of light past a heavy star, it will curve ever so slightly. It's not because it's being pulled. It's because the space the light travels through is no longer straight. It's warped. And the light, always moving forward, simply follows the shape of space. It took us a while to prove this. But in 1919, a total solar eclipse gave us the perfect opportunity. The moon blocked the sun's light, revealing stars behind it. And when scientists compared the stars' positions to where they should have been, they had shifted. Just a little. Because the light from those distant stars had curved around the sun. Einstein's dream had become reality. Let's pause here. Where are you tonight? Maybe on a couch with a cup of tea, still warm in your hands. Maybe on a train, the gentle hum beneath you like a lullaby. Maybe you're lying down, pillow soft beneath your head, letting this story lull you somewhere between thought and dream. Wherever you are, thank you for being here. Now, let's talk about something even stranger. Black holes. They are, in many ways, the most perfect expressions of gravity. Imagine a place where so much mass has been packed into such a small space that the curve of spacetime becomes infinitely steep. A place where not even light can escape. A place where time slows to a crawl. Where the outside universe stretches away like a dream. That is a black hole. But it didn't always have a name. For a long time, it was just a mathematical curiosity, a strange solution in Einstein's equations. Some scientists believe they couldn't really exist. But the universe doesn't mind surprising us. We've now seen their shadows. Felt their pull. Heard their collisions ring through space like soft, ghostly chimes. And each time, the same truth holds, the speed of light still matters. Because the edge of a black hole, the event horizon, is not a wall. It's a boundary. Once something crosses it, even light, it cannot return. Not because the black hole grabs it, but because spacetime has curved so steeply that all paths, even those going up, now lead in. It's like standing in a valley so deep that no road climbs out. And so, the light that would tell us what's inside, never makes it back. It vanishes into the curve. And yet, there's beauty in this. A quiet, humbling beauty. Because it reminds us that the universe is not cruel. Just precise. Even black holes follow the rules. Even they bow to the speed limit of light. It is not a suggestion. It is not a convenience. It is a fundamental truth. And the rest of the universe shapes itself around it. Let's drift a little farther now, into something more delicate. Time. Einstein showed us that gravity slows time. The deeper you are in a gravitational field, the slower your clock ticks. Not enough to notice, not for most of us. But measurable. Your head, right now, experiences time just a hair faster than your feet. Clocks on satellites, like the ones that help your phone find your location, tick differently than clocks on Earth. And we must account for it. Because if we didn't, your GPS would be off by miles. Every day. Every moment. That's gravity's whisper, reaching even into your pocket. And once again, all of this happens so that light's speed stays constant. It's as though the entire fabric of reality bends, flexes, and adapts to make sure light's pace never changes. Isn't that strange? Isn't that wonderful? So the next time you drop something, your keys, a pencil, a thought, remember that it doesn't fall straight down. It moves through a world that's curved. And the light reflecting off that falling object? It curves too. Quietly. Gently. Faithfully. Because that's what light does. It doesn't argue. It doesn't resist. It just follows the path the universe lays before it. Straight or curved. Easy or strange. Light moves forward. Always. So now, as you rest, as the shadows stretch long across your ceiling, as your thoughts begin to quiet, remember that even gravity, so grand, so mysterious, must honor the speed of light. It can bend the world. It can slow time. It can trap stars. But it can never outrun light. Never. Thank you, once again, for walking this winding path with me. If this story gave you something, peace, wonder, rest, I'd be touched if you shared it with another gentle soul. A quiet like, a small comment, a whispered hello, it all helps this lantern stay lit. And if you're still awake, I hope you'll join me for Chapter 5, where we leave black holes behind and explore how light lets us see everything, even the distant past. But only if you'd like to come along. Have you ever looked up at the stars and wondered, are they still there? Not in a dramatic way. Not with worry. But with curiosity. That quiet, tingling kind. Because deep down, we all know something strange about starlight. It doesn't arrive instantly. It travels. Slowly. Steadily. Faithfully. And by the time it reaches your eyes, it's been on the road for years, centuries, sometimes more. Tonight, let's follow that light. Let's ride on it like a gentle wave across time itself. Welcome back, my thoughtful companion. I'm so glad you're here again, in this soft, sleepy corner of wonder. Whether you're lying beneath a ceiling painted with moonlight or gently rocking on a late-night train, I invite you to rest easy, breathe slowly, and drift with me through one of the universe's quietest truths. If this story soothes your mind or lifts your heart, I'd be grateful if you gently liked or shared it. It helps this cozy place grow, one listener at a time. Now close your eyes, if you haven't already. And look up, yes, even with your eyes closed. Picture the stars. The wide, still night. The points of light stitched across velvet. They seem so eternal, don't they? But the light from each one carries a story that began long before this moment. You see, because light has a speed limit, it takes time to travel. A beam of light from our sun, for example, takes just over 8 minutes to reach Earth. So the sunlight that warms your cheek in the morning? It began its journey while you were still brushing sleep from your eyes. Now stretch your gaze farther. The nearest star system, Alpha Centauri? Its light takes over 4 years to reach us. So every twinkle you see is 4 years old. And if you travel deeper still into the night, you begin to see farther back. Not just in space, but in time. That's the curious magic of light's speed. Because it cannot travel instantly, it gives us something precious in return. It gives us a way to look into the past. The farther we look, the older the light becomes. Some stars you see may no longer exist. Some galaxies you glimpse may have shifted, collided, transformed. But their light, their echo, their memory is still arriving. Carried gently across the ocean of space. Let's pause. What's the time in your corner of the world? Are you listening late, the hum of a fan nearby, a blanket wrapped loosely around your shoulders? Or perhaps it's early morning, the world not yet awake, and you're drifting on the edge of sleep and thought. Wherever you are, know that the light outside your window is ancient. Not metaphorically, literally. Starlight is the closest thing we have to time travel. And telescopes? They are our time machines. Let's imagine one. High on a mountain, a great dish turns its glass eye toward the stars. It captures photons, tiny packets of light, that have traveled for millions, even billions of years. Each one started its journey before humans walked the earth. Before rivers carved valleys. Before birds flew. Some of the light we see today began its journey when Earth was a swirling cloud of dust. That light is still arriving. Still whispering its story. Still telling us what the universe looked like long ago. And in that light, we can read the history of everything. We can see galaxies as they were. We can measure the way they move. We can even glimpse the faint, ghostly glow of the oldest light of all, the cosmic microwave background. It's not bright. You can't see it with your eyes. But it's there. A gentle hum that fills the universe. The leftover light from when everything began. It comes from a time just 380,000 years after the Big Bang, a blink in cosmic time. Before that, the universe was too hot, too dense, too foggy for light to move freely. But when it cooled, light broke free. And it's been traveling ever since. We can still catch it. Still feel its warmth. Still study its patterns. That's how we know the age of the universe. That's how we know it's expanding. All because of light. Let that settle for a moment. The entire story of the cosmos, its birth, its growth, its shape, is written in light. And that story only works because light moves at a fixed, finite speed. If it didn't, we'd see everything all at once. No past. No depth. Just an overwhelming flood of brightness. But because light takes its time, we can separate now from then. We can gaze backward. And in doing so, we find perspective. A kind of peace. Because when you see a star that's 10,000 years old, you realize just how small our worries are. How brief our moments. And yet, how beautiful it is that we get to see them at all. There's a kind of intimacy in catching starlight. You're the end of a journey that began long ago, in silence and fire. You're the final stop. The last page of the letter. The reader of the sky's slow message. Let's imagine, just for a moment, that the universe is a storyteller. And its language is light. It sends its stories out in all directions, knowing some will take eons to arrive. But it trusts that one day, someone, somewhere, will look up and understand. And that someone could be you. Now breathe with me. Soft and slow. In. Out. Let your body sink a little deeper into rest. Let your mind float like a feather on starlight. You are moving through time, too, you know. Not as fast as light. But steadily. And as you move, the light continues to reach you. From stars. From galaxies. From moments long gone, still arriving. It's a quiet gift. To see the past. To witness something ancient. To remember that you are part of this great unfolding story. So the next time you look at the night sky, remember. You are not just seeing space. You are seeing time. A tapestry woven in speed and distance. And every flicker, every glimmer, every faint sparkle is a memory made visible. Because light, though it moves quickly, still takes its time. And in doing so, it teaches us to do the same. Thank you for spending this gentle moment with me beneath the stars. If this story touched something in you, if it slowed your thoughts or stirred your wonder, I'd be grateful if you shared it, softly, like a whisper between friends. And if you're still with me, awake or almost dreaming, I hope you'll return for Chapter 6, where we follow light into our everyday lives, from mirrors and shadows to phones and fiber optic dreams. But only if you'd like to come along. Have you ever stared at your reflection and wondered how it got there? Not in a dramatic way. Not with confusion. Just curiosity. Because if you think about it, your reflection isn't you. It's light. Light bouncing off your face, touching the glass, and then traveling back to your eyes, all in a fraction of a second. So fast, so smooth, that it feels instant. But it's not. It took time. A sliver of it, yes, but time all the same. Welcome back, gentle listener. I'm so glad you're here again, resting with me in this soft little corner of cosmic story time. Whether you're tucked in with the soft rise and fall of your breath or resting in a quiet space between thoughts, this moment is yours. If this story brings comfort, clarity, or a bit of calm, I'd be grateful if you shared it or left a quiet like. It helps keep this little lighthouse glowing for other night travelers like you. Now let's follow light, not through galaxies tonight, but through your living room. Let's begin with something simple. A mirror. You wake up, walk into the bathroom, and see yourself. But what you're really seeing is a tiny army of photons, light particles, that bounced off your skin, hit the mirror, and then came back to your eyes. They traveled fast. Really fast. About 300,000 kilometers per second. So the time it took them to complete that journey? Trillionths of a second. You don't notice the delay. Your brain can't measure time that small. But it's there. And if you were standing farther away, the delay would grow. Imagine standing in front of a mountain and yelling your name. You hear it come back as an echo. That sound, bouncing back after a journey through air. Now imagine light doing the same, except it moves 1,000,000 times faster, and it doesn't echo. It reflects. Still, the delay is real. Real enough to matter in the world we've built. Let's talk about phones. Right now, somewhere near you, maybe even in your hand, is a tiny screen lit by carefully controlled light. If you send a message, it travels by light, down fiber optic cables made of glass. That message bounces and bends its way through cities, under oceans, across continents. All of it carried by light. Sometimes it's turned into radio waves, zipping through the air to a nearby cell tower. Sometimes it becomes pulses in an invisible laser, racing down the hair-thin threads that make up the internet's veins. Each one moving at or near the speed of light. That's why we say the internet is fast. But fast doesn't mean instant. Even light needs time. If you were on the moon and called home, your voice, turned into a radio signal, would take about 1.25 seconds to arrive. It's why astronauts pause before answering. Even light can only go so fast. And the farther we reach, the longer it takes. A signal sent to Mars might take 10 minutes. 20, even. A message to a spacecraft near Pluto? Hours. And beyond that, the delays become days. Weeks. Years. So in our high-tech, always connected world, light's limit quietly shapes our experience. It sets the rhythm of communication. It defines the boundary between now and later. Even in science fiction, when we dream of starships and space calls, we still run into light's wall. Because unless we invent something truly new, messages will always take time to travel. A call to a distant star? That's a conversation stretched across centuries. Let's bring it closer now. Think about your eyes. Right now, they're catching light. Not just from screens or bulbs, but from everything: walls, plants, pillows, maybe the soft glimmer of the moon outside. That light reflects off objects and enters your pupils, where your brain quickly turns it into meaning. A cup. A hand. A face. But always, the light had to travel. And while that travel is fast, it's never nothing. Even the colors you see are born from how light interacts with matter. When sunlight hits a leaf, the leaf absorbs some wavelengths and reflects others. Your eye catches the reflected light, green, most often, and interprets it. But again, only because light got there. And only because it followed its constant speed. Let's slow even further. To something everyday. A microwave. Yes, even that humming little box relies on light, just a different kind. Microwaves are a form of electromagnetic radiation, just like visible light. They're longer waves, invisible to us, but still bound by the speed of light. They bounce inside the oven, agitating water molecules, making them dance and heat. Every warm meal from a microwave? Brought to you by light. You just can't see it. Or think about your remote control. When you change the channel or turn off a lamp from across the room, what you're really doing is sending out pulses of infrared light. Not visible, but still light. Still fast. Still limited by the same rule. It's everywhere, really. Light. Everywhere. Every device you use. Every corner of your home. Every glance you take. The world you see. The world you touch. It's wrapped in light. And all of it obeys the same quiet speed limit. A limit that says, no faster. A limit that shapes everything. From how long a message takes to how we define now. From how we see color to how we measure distance. From blinking clocks to satellite navigation. Let's pause again. Where are you listening from tonight? Maybe in a room with soft shadows, dancing gently as your lamp flickers. Maybe in the back seat of a car, lights passing like thoughts. Or perhaps in the still of early morning, just before dawn begins its slow yawn across the sky. Wherever you are surrounded by light. By reflections. By signals. By echoes of things just happened. And each one, each glimmer, each flicker, each glow, traveled to you at light's constant pace. Not instant. Not infinite. But perfect, in its own steady way. Now let me tell you a little secret. There are people, physicists, dreamers, explorers, who spend their lives trying to make light do more. trying to bend it, store it, slow it down, and yes, even stop it. There are experiments where light is passed through special materials, cold clouds of atoms, that slow it dramatically. Not for magic, not for fun, but to study it, understand it, harness it. Even frozen light, held briefly in a lab, still carries its story, still holds its truth, still obeys its rules. And when it's released, it resumes its journey at the only speed it knows. Because in the end, the speed of light isn't just a number. It's the heartbeat of reality. And every reflection in your mirror, every glint off your window, every quiet blink of your screen, is light. Moving, measuring, marking time. So tonight, as you rest, as your thoughts begin to slow and soften, remember, you are bathed in light. Light that travels faithfully. Light that brings you every image, every glance, every message from across the sea of stars in the curve of your own hand. And that light? It follows one rule. One gentle, unbreakable law. The speed of light. Steady. Silent. Sacred. Thank you again for joining me. If this chapter brought you ease or wonder, I hope you'll share it gently, or leave a small trace, a like, a thought, a breath of kindness. And if your eyes are still open, if your mind is still wandering, I invite you to return for Chapter 7, where we explore how light not only lets us see, but actually defines what it means to see anything at all. But only if you're ready to drift a little further. Have you ever tried walking through a room in total darkness? It changes things, doesn't it? Every step becomes cautious. Every corner unfamiliar. The familiar world fades into a vague memory, and you rely on other senses, touch, sound, memory, to fill the gap where sight used to live. But the moment you flick on a light, the world returns. As if by magic. Objects reappear. Shadows stretch. Colors bloom. But it's not magic. It's light. It's always been light. Welcome back, dear listener. I'm so glad you've returned to this calm and curious path through science and story. Whether you're resting under a patchwork quilt, the faint breeze of a fan brushing your cheek, or perhaps curled on the couch while the city hums quietly outside, you are in the perfect place for this reflection. If this journey brings you comfort, or softens your thoughts as the day fades, I'd be quietly grateful if you shared it, or left a gentle like. It helps more stargazers and slow thinkers find their way here. Now, close your eyes, yes, even now, and imagine a world with no light. What would you see? Nothing. Not blackness. Not darkness. Just nothing. Because darkness isn't the opposite of light. It's the absence of it. Without light, your eyes have no signal to catch. No reflections. No colors. No edges. Because everything you see, everything, is light bouncing off surfaces and entering your eyes. When you look at a tree, you're not seeing the tree itself. You're seeing sunlight reflected from bark and leaves, shaped into form by your brain. When you gaze at someone's face, you're not really seeing skin or features. You're seeing light, touching, bouncing, returning. Every image you have ever seen is a story told by light. And your eyes? They are not just organs. They are instruments. Light catchers. Receivers. Collectors of a constant stream of photons, rushing inward, forming patterns, translated into sight by your brain's quiet algorithms. Even the color of things is just light. A red apple? It reflects red wavelengths and absorbs the rest. Your brain interprets the bouncing red as apple-colored. But remove the light, and the apple disappears from view. It doesn't vanish. But it no longer participates in the conversation of vision. It goes silent. Let's linger here. When was the last time you noticed light itself? Not just what it reveals, but light as it is. The way it filters through curtains on a late afternoon, soft and golden. The way it dances across water like playful fingertips. The way it turns dust in the air into a floating galaxy of glittering particles. Each of those moments is light. Visible only because it's reflecting, scattering, finding its way to your eyes. And yet, light, for all its brightness, is silent. You never hear it arrive. You only see its effect. A sunrise doesn't make a sound, but it transforms the sky. Let's pause a moment. Where are you, dear listener? Are you listening in a room where light is low, maybe from a candle or a small lamp? Or are you lying in the dark, letting the words guide you gently towards sleep? Wherever you are, this chapter is reaching you through light's descendants, radio waves, screens, signals, all born from the same family of waves. All obeying the same law. All shaped by the same speed. Let's return to your eyes. Did you know that when you look at the stars, you're actually seeing photons, tiny packets of light, that have traveled across impossible distances to greet you? A star twinkles, not because it wants to, but because its light passed through Earth's atmosphere, bent by warmth and air. And your eye catches that ancient light, processes it, makes sense of it. Each photon enters the lens of your eye. It bends, slows slightly as it passes through. And then it lands, quietly, on the retina at the back. There, tiny cells respond. Some to brightness, some to color. And your brain takes those responses and builds a picture. Instantly. Effortlessly. But always, always because light arrived. And always, always shaped by its speed. Because the speed of light doesn't just define how quickly we see. It defines when we see. There's no such thing as seeing something in the present. Everything you see is a moment already past. Even the person across from you, you're seeing them as they were a few billionths of a second ago. Just a whisper behind real time. But over greater distances, that delay grows. Look at the moon. You see it as it was 1.3 seconds ago. Look at the sun. 8 minutes old. Look at distant galaxies. Millions, even billions of years gone by. Light is a messenger, but it can only move so fast. So everything you see is history. Recent, maybe. But history all the same. And yet, what a gift. To see the past in real time. To experience vision not as a mirror of now, but as a gentle cascade of moments arriving in sequence. This is what it means to see. To observe. To witness. To be alive inside light's river. And all of this, every glance, every gaze, is possible because of that one consistent truth. The speed of light. Let's drift even slower now. Because beyond what we see, there's what we don't see. Infrared. Ultraviolet. Microwaves. Gamma rays. All part of the electromagnetic family. All forms of light. Our eyes catch only a narrow sliver, what we call visible light. But that doesn't mean the rest isn't there. We've built tools to see beyond it. Night vision goggles see infrared, the warmth of bodies in the dark. Telescopes see radio waves and X-rays. Bees see ultraviolet. Some snakes detect heat. But all of it, travels at the same speed. No matter the wavelength. No matter the energy. No matter the source. So when we say the speed of light, we don't just mean the light you see. We mean the speed of everything that transmits information through waves. Everything that paints a picture of the universe onto the canvas of our minds. And because that speed is fixed, constant, unwavering, our world has rhythm, order, reliability. You might not always think about it, but every time you open your eyes, you're receiving ancient code, decoded in your brain, transmitted by light, filtered through time, made real by that gentle, unwavering speed. So tonight, as you rest, remember this. You are a creature of light. You see because light reaches you. You feel because light reveals warmth. You know the world not directly, but by the glow it reflects. And that glow? It obeys the same soft law. The speed of light. Faithful. Steady. Essential. Thank you for sharing this moment of quiet vision with me. If it brought you peace or wonder or a bit of stillness, I hope you'll share it gently, like a candle passed hand to hand. Your light helps this little circle grow. And if you're still with me, still listening, still dreaming, I invite you to return for Chapter 8, where we follow light into paradox, and ask whether anything could ever move faster than it. But only if you'd like to come along. Have you ever tried to race your own shadow? You can't win, of course. It's always with you. But for a moment, just one breathless instant, you might feel like you almost outran it. Now imagine trying to race a beam of light. Impossible, right? Because light doesn't just go fast. It defines fast. It is the limit. The ceiling. The cosmic speed cap. And yet, somewhere in the back of the human mind lives a quiet, persistent question. What if something could go faster? Welcome back, dear friend of soft science and slow wonder. Whether you're listening from a quiet room in the early hours, your phone propped gently beside your pillow, or watching the moon shift across your window pane, I'm glad you're here. This little journey through the universe is better with you. And if you'd like to help it reach more dreamers like yourself, a quiet like or share means more than you know. Now come with me, slowly, into the curious edges of possibility. Let's start with something called Cherenkov radiation. It sounds mysterious, but it's not so different from a sonic boom. You've heard of that, right? When something travels faster than sound, say, a jet breaking the sound barrier, it creates a loud, sudden crack. That's a shock wave. Sound scrambling to catch up. Now imagine that, with light. You might say, but wait, nothing can go faster than light. And that's true, in a vacuum. But in water, or glass, or air, light slows down just a little. Still incredibly fast, but not its maximum speed. And sometimes, particles, tiny, high-energy ones, can move through those mediums faster than the slowed down light. What happens then? A kind of optical boom. A blue glow. Like ghost fire under the surface. It's called Cherenkov radiation, and you can see it in nuclear reactors submerged in water. A soft, eerie light, rippling like bioluminescence from deep space. But don't be fooled. Those particles aren't truly breaking the cosmic speed limit. They're just moving faster than light's local speed in that medium. In a vacuum, the emptiest emptiness, light still reigns supreme. Still undefeated. Still the fastest thing there is. But that hasn't stopped us from dreaming. Let's talk about tachyons. They're hypothetical particles, never seen, never confirmed, that might move only faster than light. Strange, isn't it? They would always outrun light. They couldn't slow down below it. They'd be the opposite of us. But here's the rub, if tachyons exist, they break more than just speed records. They break causality. Because going faster than light would mean arriving before you left. It turns cause and effect upside down. Like sending a letter to someone before you've written it. Or answering a question before it's been asked. In the universe, it seems to really dislike that. Every experiment, every observation, every equation so far has pointed in one direction. Nothing can travel faster than light. Not matter. Not energy. Not information. The speed of light isn't just fast, it's structure. It's woven into time itself. You see, Einstein's equations don't just say that nothing can break light's speed. They say that light's speed is the boundary between time and space. Try to go faster, and time gets weird. Distances become imaginary. Causality unravels. It's like trying to walk off the edge of a painting. You don't just fall, you leave the canvas entirely. But still, we wonder. Because that's what humans do. We dream beyond the edge. There are stories of warp drives, bending space so that you don't travel faster than light, you just shorten the distance. Like folding a map. There are whispers about quantum entanglement, particles mysteriously linked, changing in sync across vast distances. But even there, no information travels faster than light. Just correlation. Not communication. No real way to send a message faster than light, no matter how entangled things seem. And yet, we keep listening, scanning the stars, testing the edges, not to break the rules, but to understand them. To ask, is light's speed a wall? Or a guide? Let's pause. Are you listening in a quiet space, where the air hums gently with late-night stillness? Maybe your eyes are growing heavy, or maybe you're wide awake, floating on the thought that the universe might still surprise us. Wherever you are, know this. The limit of light is not a failure. It's a feature. It gives the universe order. It gives time its flow. It lets stars shine, messages travel, dreams drift across the cosmos at a steady, knowable pace. And though we imagine faster-than-light ships in instant transport, the truth is, the slowness, the delay, is what gives meaning to the journey. Would a conversation mean the same if it happened all at once? Would a glance from a distant star feel as special if it didn't take millions of years to reach you? Light's delay makes room for anticipation, for stories, for longing. And in that space, we live. Because if everything arrived instantly, there'd be no room to wonder, no time to breathe, no distance to cross. So maybe the speed of light isn't a cage. It's a rhythm. A lullaby sung across the stars. Keeping everything in time. Holding the universe together. One photon at a time. So tonight, if your mind wanders to strange things, warp drives, wormholes, time loops and faster-than-light particles, remember that even those dreams are shaped by the steady pace of light. And perhaps that's not a limit. Perhaps it's an invitation. To go slow. To go deep. To go far, and still stay grounded. Thank you again for coming this far with me. If this chapter made you feel a little smaller, and yet more connected, I'd be honored if you shared it, gently, like light itself. And if you're still curious, still listening, still dreaming, I hope you'll return for Chapter 9, where we ask why the universe needs a speed limit at all. But only if you're ready to wander a little further. Have you ever played a game without rules? It might sound fun at first. Total freedom. Do anything. Be anything. But without rules, a game quickly becomes chaos. Points mean nothing. Turns blur. The story dissolves. Now imagine a universe without limits. A place where everything could happen instantly. Where every particle raced infinitely fast. Where time had no meaning, and space had no shape. Would that universe make sense? Would it hold together? Or would it fall apart before it ever began? Welcome back, gentle traveler of thought. I'm grateful to see you here again, wrapped in the hush of night or the slow quiet of early morning. If this story stirs something deep, curiosity, calm, even just a little wonder, I'd be quietly thankful if you left a like, or passed it on to another quiet mind. These small gestures help keep our little journey glowing. Now rest with me. And let's ask a strange and beautiful question. Why does the universe have a speed limit? Why must light move at a certain speed? Why not faster? Why not slower? To begin, let's think about what light's speed actually means. It's not just how fast a beam of light moves. It's the fastest speed anything can move. That number, roughly 299,792,458 meters per second, is woven into the equations of space and time themselves. It's not arbitrary. It's essential. You might think the universe is made of particles, stars, planets, galaxies. But beneath all that, the universe is made of relationships. Distances. Durations. Sequences. This happens before that. This causes that. This touches that. And all of those relationships need something to hold them together. A tempo. A pace. Something to keep everything from happening at once. That something is the speed of light. Let's slow down. Imagine the universe as a symphony. Each note is a moment. Each instrument is a particle. If everyone played at once, with no timing, no beat, No flow, just infinite speed, the music would collapse into noise. But with a fixed speed, light becomes the metronome. It gives everything rhythm. It gives space its stretch. It gives time its flow. And in that steady tempo, the melody of reality unfolds. Let's go even deeper. Einstein taught us that space and time aren't separate. They're joined. A single fabric, space-time. And the speed of light is what stitches them together. You see, when you move through space, you also move through time. The faster you go, the slower your clock ticks. But there's a limit. You can never go faster than light. Because light's speed is the slope of reality. The incline of existence. It's like the steepest hill you can climb, always upward, never beyond. And if there were no limit, clocks would stop making sense. Cause and effect would unravel. Two events could switch order, depending on who observed them. You might step into the future before you leave the present. The very idea of a moment, a now, would become slippery, unstable. So the universe says, no. Light has a speed. And nothing outruns it. Not to punish us, but to protect the story. Because the universe is, at heart, a storyteller. And stories need order. Let's bring it close now. Every time you speak, sound moves at a limited speed through the air. If someone stands far enough away, they hear your words just after you speak them. Light works the same way. If you shine a flashlight at a mirror on the moon, the light takes about 2.5 seconds to get there, and 2.5 seconds to return. That delay isn't a glitch. It's a feature. It's what allows distance to mean something. Without a speed limit, here and there would be indistinguishable. Now and then would be blurred. We wouldn't have stars, because light from their cores would escape instantly. We wouldn't have life, because sunlight wouldn't warm our planet gradually, it would flood it in a single pulse. Everything would collapse into a single moment of brightness. And then, nothing. So the speed of light is not an inconvenience. It's a kindness. It gives us dawns and dusks. It gives us seasons and shadows. It gives us time to think. Time to change. Time to grow. Let's pause. Where are you, right now? In a softly lit room? In the still dark before morning? Curled beneath a warm blanket, eyes drifting, thoughts adrift? Wherever you are, you're resting inside the great pause that light allows. This moment, right now, is possible only because the universe flows, instead of flashes. Because it unfurls, instead of explodes. Because light moves, instead of arrives. Now, some physicists have asked, what if light's speed has changed? What if, in the earliest moments of the universe, it was faster? Some theories suggest it might have been. Just briefly. Long enough to smooth out the wrinkles of the Big Bang. To give the cosmos its gentle uniformity. But even then, it settled. It slowed. It chose a pace. And once that pace was set, the universe began to bloom. Galaxies spun. Planets formed. Atoms danced. Eyes opened. And light arrived, right on time. You might wonder, why this speed? Why not a little faster, or a little slower? We don't know. It might be the only speed that allows stable matter. It might be the only way to build a universe that lasts more than a moment. Or maybe, it just is. A truth without explanation. A note struck at the beginning, still echoing through every particle. But whatever the reason, we can be grateful. Because this one, quiet limit gives us everything we know. It gives us the past, arriving gently in starlight. It gives us the present, shaped by delay and arrival. It gives us the future, hidden just beyond light's next step. So tonight, as your breath slows and your thoughts begin to ripple and settle, remember. The universe has a speed limit. And that's not a wall. It's a foundation. It's what lets the story unfold slowly enough for us to hear it. See it. Live it. One light second at a time. Thank you again for being here, for listening, for wandering gently with me. If this chapter brought you a little clarity, or comfort, or sleep, I'd be honored if you left a quiet trace, like a light traveling through the night. And if you'd like to keep going, I hope you'll return for Chapter 10, where we step into Einstein's thought experiments, and ride along beams of light through curved time and endless imagination. But only if you're ready to float a little farther. Have you ever watched sunlight dance through a window and wondered, what would it be like to ride on that beam? Not beside it. Not beneath it. But on it. Surfing light like a wave, gliding through the world at nature's ultimate speed. No wind. No sound. Just pure motion. Endless forward. That was the question young Albert Einstein asked. He wasn't yet famous. Not a professor. Not even finished with school. Just a curious mind, walking the streets of Switzerland, dreaming in silence. Welcome back, soft seeker of sleepy science. Whether you're curled under blankets while rain traces lazy lines down your window, or gently rocking in a chair beside a dozing cat, I'm so grateful to be with you again. If this quiet story stirs something, comfort, curiosity, calm, I'd be honored if you'd like or share it, so other nighttime wanderers can find their way here too. Now, let's return to that light beam. Einstein's question was simple, but revolutionary. If you could ride a beam of light, what would you see? Would the world stand still? Would clocks freeze? Would the light around you vanish? He imagined himself chasing a photon, moving alongside it, at exactly its speed. But the more he thought, the stranger things became. You see, in our everyday lives, if you chase something fast enough, it seems to slow down. Throw a ball forward while running, and it doesn't leave your hand at full speed, it starts from your motion. But light refuses to play that game. No matter how fast you go, it always moves away at the same speed. It doesn't slow down for anyone. It doesn't care if you're walking, running, or flying. This wasn't just odd. It was impossible to explain with the old rules. And so, Einstein made new ones. He realized that if light's speed never changes, then everything else must. Time. Space. Mass. Reality itself. In 1905, he published a quiet little paper. It had no grand title. Just the words on the electrodynamics of moving bodies. Inside it, a revolution. He showed that time doesn't tick the same for everyone. That if you move faster, your clock slows down, just a little. That if you travel near light speed, distances shrink. Mass grows heavier. Everything bends around light's constancy. Let's pause for a breath. Are you still with me? Still wrapped in your own little cocoon of quiet? Still floating? Then drift with me now, through one of Einstein's thought experiments. Close your eyes. Imagine you're on a train. A smooth, silent train, gliding at nearly the speed of light. Inside, someone flashes a beam of light toward the ceiling. To them, it goes straight up, then down. But to someone standing on the platform, the light must travel diagonally, because the train moves forward while the light goes up and down. So from their point of view, the light takes a longer path. But light's speed can't change. Which means, time must. To keep light's speed constant, the universe allows time to stretch. To bend. To slow. This isn't fiction. It's been tested. Clocks flown in airplanes tick slower than those on the ground, by just a tiny bit. Particles in accelerators live longer than they should, because they're moving so fast, time slows down for them. It's called time dilation. Not because time breaks, but because time is an absolute. It's woven together with space, and that fabric, space-time, can flex. Now let's go one step further. In 1915, Einstein took everything he'd learned, and made it even deeper. He realized that not just motion, but gravity affects time. The stronger the gravity, the slower time flows. Stand on a mountain. Time moves a hair faster than it does at sea level. Hover near a black hole. Time can nearly stop. Again, this isn't fantasy. We use this knowledge every day. GPS satellites orbit high above Earth, where gravity is weaker. Their clocks tick just a little faster than ours down here. If we didn't correct for that, your map would drift. Your directions would be wrong. Your position would unravel. So we adjust for time dilation, because of gravity and speed. And it all comes back to light. Because the universe curves not just around mass, but around motion. And light, moving at the ultimate speed, defines that curve. Let's sit for a moment with that idea. You are not living in a flat stage, where time ticks the same for everyone. You are in a fluid fabric. Curved. Dynamic. Responsive. The sun bends time around it. The earth bends it more. And your every step is a quiet walk across curved hours and tilted distances. And at the heart of it all, light. Still moving. Still steady. Still setting the pace. Now, close your eyes again. Let's return to the question. If you could ride a beam of light, what would you see? Einstein came to a curious conclusion. You couldn't see anything at all. Because from the light's own perspective, if it had one, there would be no time. No journey. No distance. From emission to arrival, everything would happen at once. No before. No after. Just now. But for us, for those of us moving slower, we see light's journey. We see it stretch across the years. We see it curve through gravity. We see it illuminate time. Because that's what light does. It shows us not just the world, but the rules beneath the world. Its speed is not just a number. It's a mirror. Reflecting what kind of universe we live in. One that is not rigid, but elastic. Not fixed, but flowing. And at the speed of light, time and space trade places. Become dance partners. Become inseparable. Let that thought settle. Softly. Like starlight on skin. The rules of reality. Born from a boy chasing a beam of light in his mind. And finding, not chaos, but harmony. Thank you again for traveling with me through this corner of curiosity. If this story made you wonder just a little more gently than before, I'd be grateful if you left a small echo, perhaps a like, or a whispered share. And if you're still with me, awake or gently dreaming, I invite you to return for Chapter 11, where we discover how light's speed gives rise to some of the strangest and most beautiful phenomena in physics, including, perhaps, the idea of time itself. But only if you'd like to come along. Have you ever looked at a star and felt like you were looking into the past? You are. Not in the poetic sense. Not in the metaphorical sense. But in the literal, physical, undeniable sense. That star's light may have left before you were born. And only now, after all this time, it has arrived. It traveled across darkness, over vast interstellar distances, unwavering, at its steady pace. That's what light does. It delivers messages from what was into what is. And in doing so, it creates what we call now. Welcome back, traveler of the slow and the sublime. Whether you're curled beneath a warm duvet, fingers wrapped around a warm mug, or lying in the dark with only the rhythm of your breath and this story to keep you company, I'm glad you've come back. And if this tale brings you peace, or helps you drift gently into thought or sleep, I'd be so thankful if you quietly liked or shared it. Each little echo helps another curious dreamer find their way here. Now let's step quietly into a very strange idea. Time might not exist the way we think it does. We imagine time as something that flows, like a river. Tick, tock. Past, present, future. But physics suggests something different. It suggests that the flow we feel is an illusion. And that the real structure of the universe is more like a block. A block universe. Where past, present, and future all coexist. Like pages in a book, already written. Already bound. Already there. But we, our consciousness, move through it one page at a time. And what decides how we move? The speed of light. Because light's speed is built into the very geometry of space-time. It's the edge of the cone that defines what can influence what. Imagine dropping a pebble in a pond. The ripples move outward at a fixed speed. Only things within the ripples can feel the splash. In space-time, the ripples are shaped by light. They're called light cones. And they tell us what parts of the universe can interact with each other. What can cause what? What can respond? If something is outside your light cone, it might as well not exist. Not yet. Maybe not ever. This is how time works. Not as a universal tick, but as a sequence of possible interactions. A choreography written by the speed of light. Let's float a little further. One of the strangest, most beautiful consequences of light's speed limit is gravitational lensing. Imagine this. Far away, a galaxy shines. But between that galaxy and you is something massive. A star. A black hole. A cluster of matter. And light from the distant galaxy doesn't travel in a straight line. It bends. Not because the light is curving itself, but because space is curved. Gravity, as Einstein showed, is the warping of space and time. Mass bends the fabric. And light, faithfully, always, follows the path of least resistance. So it curves around stars, loops around galaxies, and sometimes creates illusions. Multiple images of the same galaxy. Rings of fire in the sky. Mirages of light. This isn't science fiction. It's been photographed. Studied. Understood. We call them Einstein rings. Formed not by magic, but by the simple, steady rules of light and space. And they remind us, what we see is not always where things are. Because light takes time to arrive. And its path can be twisted, delayed, scattered. So the night sky is not a map. It's a time machine. A layered image of things that were arriving in a shimmer of moments. And in that shimmer, we find something even stranger. The universe is expanding. Not like an explosion, but like rising bread dough. Galaxies aren't flying through space. Space itself is stretching. And because of that, light gets stretched too. Its wavelength grows. Its color reddens. This is the redshift. The further a galaxy is, the more stretched its light becomes. And that stretching tells us how fast space is growing. Some galaxies are moving away faster than light. Not because they're breaking the limit, but because the space between us is expanding. And light, trying to cross that ocean, can never reach us. It gets stranded in the stretch. Its message fades before arrival. It's as if we are inside a great balloon. And though the light sets out toward us, the balloon keeps growing. And the light falls behind. This is why we'll never see the whole universe. Because some light, though moving at the ultimate speed, will always be too late. Too far. Too delayed. And yet, we still try. We build telescopes that look not across, but back. Back in time. Because the further out we look, the older the light becomes. We can see galaxies as they were billions of years ago. We can see the echo of the Big Bang, the cosmic microwave background. A glow not from stars, but from the birth of light itself. A whisper from when the universe became transparent. That light has been traveling for over 13 billion years. And it's still arriving. Now. To you. To us. To this moment. Let's pause again. Are you still listening? Still with me in this quiet sea of slow time? Maybe your thoughts are drifting, like light through dust. Maybe your eyes are growing heavy, tracing shadows across the ceiling. Wherever you are, this moment is stitched into the fabric of space-time. Unrepeatable. And light's steady pace is what makes it real. Because without that limit, without the delay, without the patience, we would see everything at once. And nothing would have meaning. So when we ask why light has a speed limit, we're really asking, why does anything take time? Why isn't everything instant? The answer, perhaps, is simple. Because meaning needs time. Because stories need sequence. Because wonder needs waiting. And the delay of light gives us space to imagine. To remember. To hope. You, right now, are made of atoms forged in stars whose light still travels. You are lit by the past, shaped by delay, connected by photons that took their time. And that time is a gift. A quiet one. Wrapped in starlight. Thank you for floating here with me again. If this story sparked even a soft flicker of wonder, I hope you'll send it onward, so another kindred listener might follow the light. And if your eyes are still open, your thoughts still gentle, I hope you'll return for the final chapter, Chapter 12, where we ask, what would the universe look like if light had no limit at all? But only if you're ready to dream one last dream. Imagine a world where everything happened all at once. Where the moment a star was born, you saw it blaze. Where distant galaxies blinked in and out of your sky like fireflies in a field, not light years away, but right here. Where time itself had no rhythm. Just one blinding moment, an eternal now. Would that be peaceful? Or overwhelming? Would it be beautiful? Or unbearable? Welcome, dear listener, to the soft end of our journey. Whether you've traveled through these chapters with eyes wide open or drifting shut, I'm deeply thankful for your company. And if these quiet explorations brought you peace, curiosity, or rest, I'd be truly grateful if you'd like or share this final chapter. A soft gesture that helps this little light reach another quiet corner. Now, let's imagine, just for a while, that light had no speed limit. That it traveled instantly. What would change? Everything. Because distance would no longer matter. A whisper from across the galaxy would arrive before the thought had even formed. A signal from a faraway world would reach us before it was ever sent. We would see the entire universe, not as it was, but as it is. No delay. No waiting. And time would lose its shape. You see, it's the delay, the space between sending and receiving, that creates the illusion of flow. The tick between cause and effect. The breath between question and answer. Without it, all things would happen together. Stars would flicker from birth to death in a blink. You'd see every galaxy, every collision, every supernova, not layered in time, but stacked, endlessly, upon your vision. No past. No future. Only now. And strangely, you wouldn't be able to see it all. Because without a delay, there would be no way to perceive motion. No before to compare with after. No distance to frame a view. Your eyes, evolved to interpret light over time, would be overwhelmed. Your brain, built to find patterns in the delay, would find none. Vision would collapse into brightness. Not illumination, but overload. And space? It would feel flat. Because part of what gives depth to the cosmos is the layering of time. The light from a star arrives with a whisper of age. The glow of a galaxy bears the stretch of expansion. Even the moon, just over a second away, reminds you, all vision is memory. But with no limit, all those layers vanish. The universe becomes an infinite mirror. Everything seen at once. And nothing understood. Let's slow down. Would life even exist in a world without delay? Could atoms form? Could heat escape? Could energy ripple and bounce? The answer is, likely no. Because delay is not a flaw, it's a function. It lets things cool. It lets things combine. It lets reactions take time to unfold, to stabilize, to breathe. Stars need time to fuse. Planets need time to settle. Life needs time to grow. And light's speed gives us that time. Not too slow. Not too fast. But just enough. Like a lullaby that drifts, note by note, across the dark. A limit, yes. But a gentle one. A boundary that holds the world together. And gives it shape. Let's rest in that. Because the truth is, we live not despite the delay, but because of it. The seconds between heartbeat and breath. The minutes between nightfall and sleep. The years it takes for light to cross the gap from star to soul. These are not gaps to be closed. They are the spaces where meaning lives, where memory is born, where story happens. So perhaps it is not a question of why light has a speed limit, but a quiet celebration that it does. Because in the waiting, we see, we think, we feel, we dream. And now, here you are, at the soft end of this long, luminous journey. Still listening, still dreaming, still riding the slow, golden thread of curiosity through the dark. Thank you for your time, your mind, your trust, and your quiet attention. You are a part of this story now. And if it brought you peace, if it helped you sleep, if it left you with a flicker of wonder, I hope you'll share it gently, like passing a candle through a quiet room. And perhaps, when you look up at the night sky, at those scattered sparks that took so long to reach you, you'll remember. You are not separate from the stars. You are made from their stories, woven with their light, bound, softly, by the very limit that gave rise to all things. And that limit? It is not an end. It is the beginning. Always, always beginning. Good night, traveler of light.